This is Group 6, and it's our pleasure to present you guys with our final project, which is Tetris AI Challenge. So let's start with the purpose of this project. Since we want to build a quite classic and old game, which is Tetris, and we want to add new features into that old game, which is AI mode, AI competition mode, and we spend some time investigating which AI approach or AI method we have to implement. So we found there's actually several AI approaches, and we want to investigate what's the pros and cons of choosing different AI methods. For example, the heuristic-based artificial AI approach or the DQN learning, which is a quite classic reinforcement learning. And also, we want to investigate what is the difference between different deployment methods. For example, deploy it on the cloud function, or we deploy it on the server side, or we can just deploy it on the client side, like the local machine of the user. And we want to investigate the pros and cons. So this is today's outline. We would first look at our project. We will dive deep into the technique we used and some implementation details. And next, we would have a live demo of our project. And finally, comes to the conclusion section, which is we would analyze different methods and draw our conclusion. So let's start with the project overview. Just like other normal full stack project, there is front end and also the back end. And besides, we have the AI model section. Um, and within each section, we would talk about the technique we used and why we use that, and also some implementation details. So let's start with the front end. Um, so just like other project, we use the combination of React and Next.js as the front end library and the front end framework. And also we use Tailwind CSS to style our component. And also we use ZooStand to manage the game state. And as for the backend and AI approach, we use Firebase to host our static web page, and we use AWS EC2 as our server to deploy our AI model. And as for the AI approach, we actually invested in two different approaches. The first one is heuristic based AI, which we will talk later, and the second one is DQN learning. And here's a graph illustrate what it does. There's actually two main components, the agent and also the environment. The agent would observe the environment, and based on the environment, based on the current state, it would take action. And the environment would, based on the action they did, give back response or give back rewards to the agent. The agent would then, based on the rewards or the response, train its neural network, which is how they make their decisions. And so, let's dive deep a little bit into the AI methods. The first AI method is heuristic-based AI. So the overall idea of this method is that since we know for each falling touch middle, there's a lot of actions you can take, which is, for example, moving right or rotate them. So in this method, we will compute a score for each possible move. And how we calculate this score? The score is based on four main criteria. The first one is lines completed. The second one is aggregate height, which is also the overall height. The third one is bumpiness. The final one is host. And now let's look at these four criteria. The first one is lines completed. The light blue lines actually refers to the line that would be cleared, or the line that is completed after the touch middle fall onto the ground. So we know there's actually two lines cleared. And the second parameter is overall height. It's quite obvious, right? This column the height is 3, this column the height is 5, and the overall height is 48. And the third one is bumpiness. And on the left hand side, we see that there's actually a huge gap between two different columns. And now you can see the height, the height gap is, for example, here is 6. This line, the height is 6, and this line, the height is 0. And on the right hand side, this graph, this game board is actually a lot more flattened. And so the bumpiness is actually relatively low, which is 4. And on the left hand side is 20, which is relatively high. And we want our model to prefer these kinds of the game board, right? So the final one is host. which is quite obvious, and I don't want to explain more. There's two hosts, and that's how it is calculated. So let's come back to this score. The score is calculated. Here's a formula for calculating the score, and there's four parameters. The first one is A, B, and the ABCD refers to the coefficients. And in this approach, we manually selected and tested these coefficients. They're not trained by the neural network or anything else. We just manually select them, but they did achieve a relatively good performance, which we will talk later. And this approach is purely embedded in the front end JS code. We didn't deploy it on the back end. And now comes the deep code learning. So compared to heuristic-based AI, they both use the same four criteria, like the lines clear, the overall height, the bumpiness, and the holes. However, the goodness of an action is no longer calculated by the linear function like we showed previously, this one. It is not calculated using this formula. It is calculated by the neural network, which is, since we know that neural network can actually represent a more complex and a non-linear function. So it's not surprising that they can have a better performance. And as for the parameters, how they calculate these parameters on each node, they actually um, through the interaction with the environment, since the environment will give back the response, and based on the response, they will do backward back propagation and do some gradient descent and calculate the parameters on each node. That's how it is trained. So now let's go to the live demo section, and I would like to first show you how how our neural network is actually trained. This is demo of how it is a visualized demo of how we train the deep learning network. And here is our website. You can access it from tetris.deku.com. And we're not going to talk about the sprint and infinite mode. We'll just go straight into the AI challenge. And on the left hand side is actually controlled by me, the human player, and the right hand side is actually the AI controlled. So I think you might notice that it takes some time for the AI model to give a response, and that's probably because the model is deployed on a server and it takes some time to give back response to the front end and render it. And the current version is a medium level. So once we switch to, for example, the hard level. So now let's go back to the analysis and conclusion section. Um, here are several metrics that is used to um, compare the different approaches. For example, the deployment and the response time and scalability, maintenance, performance. And here are three different approaches. The first one is heuristic based AI. The second one is DQN that is deployed on the server. The third one is DQN deployed on the cloud function. So I'm not going to go through the whole table. I will just pick up some important features. For example, the response time. As for the heuristic-based AI, since it is purely embedded in the front-end JS, it could give an instant response. And for the DQN deployed on the server, the response time is around 0.3, 0.5. It actually depends on the network, right? And as for the DQN deployed on the cloud function, sometimes it takes a lot more longer. For example, 6 to 7 seconds. That's purely because um, for the count function, if nobody is calling it, the results would be released after some time, and we should call it cold start. So sometimes it take a lot more longer to respond. And the next feature I would like to talk about, the next metrics I would like to talk about is performance. There is So for heuristic based AI, normally it can clear 2,000 lines or more. Compared to the DQN, it's not a good performance, but I think it's totally enough to beat a normal player. And as for the DQN, uh, this model's performance is relatively high. It can sometimes reach like 20,000 lines. But the problem is, DQN is sometimes not reliable. For example, for some corner cases, for some extreme game status, game state, sometimes it doesn't, like it terminates really quick, like 100 lines it can terminate. So that's the drawback of this model. So here comes our conclusion. For heuristic based AI, it's easy and fast to deploy since it is it's purely embedded in the front end, and the performance is not that good, but like we just said, it can be amateur player, and it's suitable for demo or prototype, and we can later change to a larger AI model like the DPQ learning. So the DPQ learning takes actually have a much better accuracy and much better performance, but with this comes with a little bit longer response time because we have to go through the network to get the result, and also it takes a lot more time to deploy and maintain. But I think it's worth it. And with the growing user, we can easily scale up since it is deployed on either server or the cloud function, and we can just buy more server or buy more throughput of the cloud function. Okay, so that's all. And here's the bibliography or the reference of our project. If you're interested, you can just go visit them. And that's all. Thank you for listening.